Thanks so much for the opportunity. And I guess I am going to maybe elaborate on what everyone else said, talked about edge cloud and also with respect to where we are going with 5G. But before I do that, I remember my younger daughter, when she was 3 or 4 years old, she told me her first joke, and she was very much proud of it. And it had to do with why is monkey eats the banana with the peels? And then they asked the monkey, why do you do that? And then he says, why should I peel it off? Because I know what's in it already. So I'm going to tell you a little bit more about really more details in terms of where we are going and why open source. Okay, so I guess with that, I need to sort of tell a little bit more about driving force behind 5G and why this whole open source networking is important to the industry as a whole, and why it is disruptive, etc. And what is it that AT&T is thinking about for the past 4 or 5 years that I've been involved with open networking and supporting AT&T, representing AT&T in various open networking aspects and all of that. So historically, it is obvious that a lot of the infrastructure that we have in our central offices, Faraz mentioned about a few thousands of those infrastructures that we have, COs or central offices in various places. And it was because of this basically purposeful hardware that was supporting us, and we wanted to sort of move that more towards software-defined, where we could take advantage of these democratized interfaces and so on. So with that, we had to think about the ecosystem. Our ecosystem were pretty much these larger vendors, Cisco, Juniper, and Ericsson, Nokia, etc. And we had this artificial wall between us, between basically, the content providers, operators were in between. Now we are also a media company. We also have some content. And then ODMs and IC vendors and IPR vendors, they were all in this side. So we would never get a chance to talk to ARM, for example, because they are IP company, or some innovators in a startup, we would never get a chance. And that whole ecosystem is changing, and that's why you see all these open development activities mushrooming out, where we sort of are creating the operators talking to OEMs, to IC vendors, ODMs, and we're sort of empowering our customers to be more in control per se. So with that, it comes these emerging operating models that, economically is viable ecosystem that we can work with everyone. And everyone talked about my colleagues talked about, these emerging applications, AI, robotics, flying objects, microservices, and third-party applications. They all can be part of the ecosystem as we go forward. So the rise of Open RAN is the one thing that I want to tell you, about what's in it, that we talked about, right? And really this whole Open RAN is more of moving us more of towards unified SD-RAN. For a long time, we had to be dependent on these purposeful switches and hardware, and now we are slowly moving. How do we open up the whole mobility? How do we make it open, SDN enabled, and take advantage of really these, 5G emerging releases, 15 and 16 and beyond with these open platforms. So I won't bore you with the details of the value of the 5G with respect to, MIMO, multi-rat, and massive MIMO, especially with the beam patterns, beamforming technologies that it can be really controlled from the software-defined radio perspective. So with that comes really separation of control from user plane. This is, if you guys remember all the talk from Stanford, initially with SDN and why SDN was important. If you look at really what is in it, right, in terms of the stack, the RAN stack, there are many of these, what you see on the right side, which is all the control plane functions of the RAN, which is really RRC control and, ICIC control, paging control, everything you see without me going through all of them. And then you have the user plane functions. The user plane functions are where the payload really, takes place, all the traffic goes across, and you have to go through the MAC and PHY and a low part of the PHY, high part of the PHY. And this is where we are thinking that we could have function as a service, right? Some of these functions can be done. Once we have it in disaggregated mode, then the innovation happens much faster. We could move things around into different DU, CUs. We can have different dynamic split architecture options for 5G. And as you know, with LTE, we had a single base station. All the stack you see here was in a single base station. Now, by separating them out and putting some XRAN or APIs associated with this whole stack, now we should be able to control it from software-defined RAN and hopefully innovate faster as we go forward. So some of the radio resource manager functions, for example, just giving a common control and configurability with respect to split architecture that we are talking about, extending some of the control configuration options to split vendors. How do we configure A vendor from the B vendor, et cetera? And more importantly, we talk about virtual probe, both from hardware and software perspective, right? Virtual probing, I think somebody alluded to that. I think my previous speaker talked about, it's important to take advantage of the analytics in a real-time basis where we can have virtual probes not only at the software level but also hardware level, where we can expose applications to the network and vice versa. We can no longer network and applications are blind to one another. And it comes from those dynamic virtual probes. So I'm emphasizing on this because I'm hoping that as we are innovating around solutions, just like people saying security is part of the architecture, probing is part of the observability, is part of the emerging architecture that we need to think about going forward. And it comes capabilities that we show here in terms of handoff, in terms of scheduling, in terms of RAN slicing. All of that comes from ability to be able to observe and be able to take an action. So open reference platforms, right? This is what Intel has been good at, and thanks to them, they've been basically contributing heavily in these open reference platforms. With that, they've been talking about really offering new user experiences, enabling developers to develop faster with the rest of the community, and provide new types of connectivity that we haven't thought about, perhaps. Some of the innovators here, I was very impressed in terms of its I/O and mesh services that they have provided, and providing basically this autonomous operational flexibility. We no longer, with that number of radios that are out there, we no longer can really manage the 5G network with centralized policy-driven approach. We sort of need to think about autonomous approach, and we need to think about maybe zero-touch operation. That's where we have to take advantage of the machine learning, AI, predictive analytics on top of radio intelligent controllers that we can expose and all of that. So this whole thing leads to this adaptive analytics for 5G, which we talked about, maximizing the throughput and connectivity and more efficient data handling approach. And that comes in all the various capabilities and support that comes with 5G and all the promises that 5G provides. Now, let's talk about rise of open reference platforms. ORAN, for example, XRAN, ORAN, you guys might heard of it. Now, we used to know 3GPP very well, where they would innovate or they would come up with the standards and everyone goes and certifies equipment based on these 3GPP standards. And now we are slowly looking at what ORAN specification and how fast community can put these reference platforms together. As a result of these reference platforms that are out there, right, and I'm sort of showing here an example of a ONF activities that I've been involved with, and what does it look like in terms of really open reference platform, how the user plane, converged user plane for both RAN and core can basically be managed by the SDN, and how access as a mobility RAN side can be attached to this user plane, and maybe even multiple access, different type, wired, wireless, Wi-Fi, 5G, 4G, they all can converge for a single user plane, and then we can have a lot more opportunities for functions. So what you see here is sort of represents a sort of an architecture, reference platform that we could have SDN, we could have basically configuration management on top, we could have a slicing management. Some of you mentioned, how do we do the, basically provide this shared environment that we are in today. With the slicing, we should be able to control that in a much better fashion. So open source communities and standards, somebody asked the question, what about 3GPP? I mean, we are used to going certifying things, and then everything gets launched and all of that. Things are changing. Believe it or not, there are opportunities, for various deployment models with open source solutions, and we are going to see more and more of that with open reference platform at the heart of it, and then you're basically sugarcoating it with some proprietary applications, proprietary software, and innovation around it. And slowly you bring in whatever has been certified by ORAN or by XRAN or by 3GPP. You try to meet those as you go forward. So this model that we used to be in 3GPP standards had to be there first. Then you put your physical network infrastructure, then you deploy. It's conceptually changing. The operators like us, we've been asking, can we have 50% open source, and the Tabasco sauce could be proprietary, right? That was John Donovan, many years ago, he said that. So this whole model of 3GPP standards and open source community sort of collaborating, they are complementing one another, and is going forward, much better. So let's look at this quickly. What does this impact of open source platform means, right? We are sort of adopting microservices. It's obvious that those innovators who are looking at Kubernetes containerization, they are even looking at what limitations and gaps are within containerization are. So we are thinking of really everything as a service, right? There is a logical controller for applications, for infrastructure, for VNFs, for SDN, and then the resources on the bottom are basically controlled by those. So with them, are democratizing this architecture in a sense. Okay.
How far do you see the microservices into deployment in the NFV SDN area? How far out do you see?
Microservices to me means really that CI/CD model, and it means to me that you're no longer having these monolithic applications and you're breaking function as a service and all of that. More and more, we have been innovating for some time, even including ONF. They're taking these monolithic approaches and breaking down into a smaller containerized environment and all of that. So, for example, SIBA project, which is really open part of ONF, is really, we are rewriting it based on Go language, to make it more microservices, so it's happening, so CI/CD means that I might deploy with solution A, but doesn't mean that I cannot have new release every day. So it's going to evolve towards that. So by 2020, I would say you're going to see some good samples of set of deployed microservice environment. And that is what this whole open democratized RAN means, that you're trying to be able to adapt to these. I don't want a scheduler, for example, from vendor A, and I might just use some startup garage develop scheduler. I should be able to switch that scheduler and put it in there. Or I might build my own scheduler or slicing manager within there. I do not want to be at the mercy of big vendors to operate with my most scarce resource, such as my spectrum, right? So that's sort of the model that we are going in on that.
Thank you.
Sure, my pleasure. And then abstraction is everything, right? How do you program the network infrastructure? I don't go to the details here. I had a bad picture in here, but that blue is supposed to represent sort of the infrastructure of mobility in that case. So I'm just showing you a sort of a graph abstraction representation of radio network that I came up with, right? How do you represent a set of basically routers? How do you represent a set of links, the links within the mobility? How do you represent basically beams, right? A set of beams that you're supporting, multiple beam and beam patterns and all of that. And so if you can create this right abstraction model, then there is opportunity for programming the graph rather than worrying about whose equipment am I configuring, or is it an Ericsson, Nokia, or some third party, or some open platform, reference platform. So the applications don't have to change. Applications only see the radio network intelligent, database as a graph, and they program the graph in a real time. If we do this right, I think we can meet the performance, and hopefully with ORAN it goes forward and all of that. So since I have 5 minutes, let me just quickly summarize in where we are going with respect to programmable RAN operation, right? The sort of RRC, which is the radio resource controller, that controls the handoff and admission control and all of that, it can come really to run in the cloud, right? It can run at the edge of the network. And then the red PDPC, where we can do carrier aggregation and all of that, could be part of that, CU function. Some of the RLC or MAC and PHY layer could be part of the distributed unit, which is closer to the radios, right? And sort of you could tell that the reason with this whole interfaces that we are showing with these open APIs, we should be able to disaggregate and we should be able to manage a better networks going forward. So with software-defined RAN and microservices, you mentioned that this is an example of really, having a local RAN agent controller, for example, with virtualized microservices on the bottom, and then how we can have this radio resource abstraction graph programmed by the applications on top, right? The policy, the carrier aggregation and virtual RAN application, slicing manager, all of that they can basically control. And M-Code, which is close to my heart, which I really initiated at ONF, and so we are sort of trying not to move that more of a converged access technology, basically both mobility and wireline technology. And M-Code is one of the access now, and the rest of it becomes basically part of the infrastructure going forward. Now, this is sort of an example of, what I'm talking about in terms of if we put this pod together, we have the virtual RAN controller in the center, based on Acreno, that I think Faraz's slide showed that a little bit in terms of the blueprint of how we are going to fit this into that environment. Then we have all this infrastructure, VMs, VNFs, in form of containers or some microservices, and we are sort of providing these active and passive probes on the bottom, and how we are going to measure what's going on with these 5G components. Those are all the stack I was showing you as the 5G components. And with that, then we should be able to give the applications on top of what they want. Here is an example of adaptive analytics that we tested with at ONF, and it was really providing active and passive monitoring, active testing and passive monitoring, where the application says, I need this, and therefore we were providing some form of virtual probe running in a VM at that time. Now it could be containerized, and those active testing takes place live in operation, where we could measure make those measurements and decide whether we should elastically increase a slice or move a UE to a different slice, for example, or increase the quality of service, and other measurements that we need for beam forming, beam pattern, going forward. And I think sky is the limit in terms of once you know what is going on in terms of your radio infrastructure and all of that, it becomes easier and all of that. So my summary slide with 1 minute left, it says aggressive spectrum allocation for 5G and beyond. Of course, it will require a unified, open, and democratized interfaces, right? And that's part of why we have to do this sub 6 gigahertz if you want to be able to have software-defined radio and all of that. We are opening up the interfaces, disaggregating the RAN. We are deploying white box DUs and RUs, and ORAN, which is really the basis for specification of how these architecture of these open platforms are, is slowly going to get pushed to the 3GPP as a contribution, and hopefully they will collaborate. And last but not least is opportunity for open source and machine learning and in-band network telemetry that I talked about are the key part of the 5G and all of that. So with that, I want to thank you, and if there's any questions, I'll be happy to answer if there's still more time.